Hello everyone, let's try to be a cheat code ninja today. In this problem, we have to reverse a linked list. You will have to use this concept in so many different linked list problems. So let's look at it. In this example, all the pointers of the linked list are reversed and the last element 5 becomes the new head of the linked list. Let's try to come up with an intuitive solution for this. Let's represent a linked list by two null pointers on both the ends. If we just consider this node, the null pointer to the left of it, even though it's not connected to 1, it's the previous node, and node 2 to the right of it is the next node. So when we are trying to reverse a linked list, the next pointer of a current node 1 should point to the previous node null. Similarly, this link should be broken and the next pointer of the next node 2 should point to our current node. But before we do that, we have to store the reference of our next node. This is because the next pointer of the current node is pointing to the previous node. Hence we don't have its reference anymore and we should store it in a variable before we update the next pointer of the current node. We have to repeat this process for the rest of the linked list. So our current pointer along with these two pointers will move forward. So we'll repeat the same thing for the second node. Similarly, we'll update these three pointers and repeat the same process. And finally, when our current node is the last element of the linked list, our next pointer has already become null. So when we go forward, our current pointer itself will become null. So there are no remaining pointers to be reversed anymore. And our previous node will become the new head of the linked list. So we have successfully reversed a linked list and returned its new head. This can be done both iteratively and recursively, and we'll implement both of them. The time complexity of this would be O of n because we only have to go through all the nodes once. And the space complexity would be constant in the case of an iterative solution because we are only maintaining 3 pointers. And in the case of a recursive solution, it would take O of n stack memory because of the recursive call stack. Let's implement both the solutions. Initially, our previous pointer will point to null and our current pointer will be pointing to the head of the linked list. We'll continue to go forward as long as our current node is not equal to null. Since our current node will now be pointing to the previous node, let's store the reference of the next node so that it is not lost. Now we can update our current node to point to the previous node. Now we are done updating the pointers for this node. But before we continue, our previous pointer will now point to the current node. And we'll update our current pointer to point to the reference of the next node that we have stored. And finally, after this loop, our previous node will become the new head of the linked list. So we'll return it. We are done with our iterative solution. Let's implement the recursive solution. We'll define a recursive function which takes two input parameters, our current node and the previous node. We have defaulted our previous node to be null because initially our previous node will be null. We'll write the base condition of this function. When our current node becomes null, in that case we'll return the previous node. We'll do the same thing as in our iterative function. We'll store the reference of our next node and we'll update the current node to point to the previous node. And finally, we'll call this recursive function with our next node becoming the current node and our current node becoming the previous node. Whatever is the output of this will be the new head of the linked list. So we'll return it directly. Finally, we'll call this recursive function with the head as the current node and the previous node being null. Let's submit our solution. You can see that our solution is accepted. If you have any doubts or concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.